as I have shown you, it can be tilted whatever position you want to do it. Then it is provided with an oxygen lens through which pure oxygen at high pressure and with supersonic speed can be admitted on the molten iron. The oxygen that will be sent from here will be at very high pressure and at supersonic speed. Supersonic speed means even the speed is greater than the speed of sound. The oxygen, the speed of sound. So, oxygen is sent from here at a very high pressure and supersonic speed. The lens has a water jacket also, water cooling jacket is also there for so that if we want to cool the oxygen, we can cool it also. In this case, the charge consists of molten pig iron, scrap iron, small quantity of lime is also introduced through oxygen lens, and it is kept vertical above the metal surface. Pure oxygen at a pressure of about, this is 100 atmosphere, is passed at supersonic speed of 100 to 150 meters per second. The impurities in the charge are rapidly oxidized. Now, here we have the charge. The impurities in the charge are rapidly oxidized. The volatile gases escaped out and others pass into the slag. Same method is here. I will show you the reactions now. Just have a look at the diagram so that we can revise the reactions. These are the reactions. The carbon with oxygen, it will be oxidized to carbon monoxide, CO. Sulfur plus O2 will give SO2. Phosphorus plus O2 giving you P2O5. Silicon plus oxygen giving you silicon oxide. Manganese plus oxygen will give you manganese oxide. So, these are the various oxides that are formed. The impurities of carbon, sulfur, phosphorus, silicon and manganese are converted into their oxides. As we have seen in the last process also, the carbon monoxide and sulfur dioxide being gases, they will move out. Phosphorus pentoxide and silicon oxide and manganese oxide, they will react with manganese oxide react with silicon oxide to form manganese silicate. Calcium oxide will react with silicon oxide to form calcium silicate. Calcium oxide and P2O5 will form calcium phosphate. These three, MnSiO3, CaSiO3 and Ca3PO4 whole twice, these three will form the slag, and these carbon monoxide and sulfur dioxide, they will move out as gases. From here the gases will move out and the others will form the slag over here. This is the molten steel that is being formed, this lower portion, are you seeing here, this portion, and this upper portion, this is the slag of manganese silicate and then calcium silicate and calcium phosphate. So, slag will be of manganese silicate, calcium silicate and calcium phosphate. Now, as the impurities get oxidized, the temperature increases and a hot spot is created near the center of the charge. At this place, a hot spot will be created. Molten metal being heavier will sink to the bottom, as I have told you. The molten slag and impure metal exposed to the incoming gas from the lens, we can tilt it and we can pour out the slag first, and then required quantity of spigalacine is added to the pure molten iron so as to convert it into steel. When the carbon content is obtained, we can convert it, spigalacine will be added. We have seen that spigalacine is an alloy of manganese, nickel, that is being added to the steel so as to convert it into steel, to the iron. Now, the advantages of LD process. This LD process is faster and requires less energy. It is more economical since it uses lots of scrap iron. The elimination of sulfur and phosphorus is complete over here. Nitride formation is avoided. The lining of converter is kept intact due to smooth movement of the contents. The lining doesn't get destroyed, and the quality of steel that is obtained is better or superior as compared to the open hearth process. So, LD process, now this is the latest process for manufacturing steel. This is a better method, it is faster and requires less energy. The open hearth process was a slow process. This process is more economical because over here we can use lots of scrap iron and all the gases, impurities are properly removed. So, these are the advantages of LD process. So, we have seen two methods for manufacture of steel, the open hearth process and the LD process. Now, I would like to discuss, because once we have made the steel, we have to do certain heat treatments on steel. So, first I would be discussing about the various heat treatment of steel. So, basically what is stainless steel? It resists corrosion by atmosphere. It essentially contains chromium along with nickel. Chromium is more effective in its content and protection is more against corrosion due to formation of dense tough film of chromium. We have three types of steel: stainless steel, then we will be having nickel steel. Here nickel is there, it improves the tensile strength and ductility. Then we have Alnico steel, where aluminium is there. Now, let me first discuss about the heat treatments of steel. The first heat treatment is normalizing. In this process, the steel is heated to a definite temperature which exceeds its upper critical temperature range and then allowed to cool gradually and freely in air, and this makes the steel homogeneous. Its internal stresses are minimized and the mechanical properties are enhanced. So, in normalizing, steel is heated to a temperature and then it is allowed to cool gradually and freely in air. Second heat treatment is annealing. Annealing. Here the steel is heated to a temperature well above the red heat. Matlab, the steel will become red hot and then it is cooled slowly, and this process makes the steel soft. So, this is annealing. Next is quenching or hardening. This process is used to make the steel hard. In this case, the steel is heated to red heat at about 850 degrees centigrade and then it is suddenly cooled by plunging it into cold water or oil. Suddenly we are heating it first to 850 degrees centigrade and then we are cooling it suddenly. So, this makes the steel hard and brittle. So, this is quenching and hardening. We have seen three steps: normalizing, we heat it and we cool it slowly till upper critical temperature. Then in annealing also we are heating it to red hot and then we are cooling it slowly, and in quenching or hardening we are heating it to red hot to about 850 degrees centigrade and then suddenly we are cooling it. The next process is tempering. In this case, the quenched steel, that the steel that we heated and we cooled suddenly, that steel is reheated to a temperature of 230 to 300 degrees centigrade and then it is allowed to cool slowly. This makes the steel hard but not brittle. The quenched steel became hard and brittle both, but tempering makes it hard but not brittle. the fifth process. It is case hardening. A hard wearing surface is produced on mild steel or steel having a core inside. By surface carburizing, we will carburize the surface and then we will quench it in water. So that process is known as case hardening. We are preparing a layer on the steel and then we are quenching it in water. Then the sixth heat treatment is flame hardening. In flame hardening, we are heating an area of steel by means of oxyacetylene torch followed by abrupt cooling by water spray. We are heating by oxyacetylene torch and then we are cooling it abruptly. So this is the flame hardening process. And the next is nitriding. Nitriding consists in heating metal in presence of nitrogen at 340 to 350 degree centigrade. So that is known as nitriding. So we have basically 7 methods of heat treatment. The first is normalizing, in which we are heating it to a definite temperature, we are cooling it slowly. Then we are having annealing, where we are heating it to a temperature above the red hot and cooling it slowly. Then we are having quenching, in which we are heating it to high temperature of red hot and then we are cooling it suddenly by plunging it into cold water or oil. Then we have tempering, in which the quenched steel is reheated to 230 degrees centigrade and then it is allowed to cool slowly so as to make the steel hard but not brittle. Then we have case hardening, in which a mild core is a layer is formed by carburizing and then it is quenched in water. And then we are having flame hardening, in which a frame of oxyacetylene is put on it and then it is cooled by water spray. And then the last method is nitriding, which consists in heating the metal in presence of nitrogen at about 340 to 350 degree centigrade. So today we have discussed about what is steel, basically the types of steels we have discussed, and then we have discussed about the manufacture of steel. The manufacture of steel is by two processes, the open hearth process and the LD process. The main purpose is to get required quantity of carbon. These are the diagram of open hearth process. Then we discuss about the LD process. This is the LD furnace. And then later on I have discussed about the types of steel, that is the stainless steel, the nickel steel and the Alnico steel. And later on I discussed about the heat treatment of steel, that is normalizing, annealing, quenching, case hardening, tempering, flame hardening, etc. So I hope you have understood the lecture quite well, and with that I finish my lecture. Thanks a lot.